What's up guys, this is Professor Spawn. In the last video we have seen about the comparable demo and we have implemented an employee class, right? And this employee class implemented a comparable which is of type employee. And here we have implemented one method which is a compare to, and here we wrote our logic, right? But then the first we did a sorting based on salary, but if you wanted to do based on, let's say, a first name, then we need to actually comment this logic, and then we had to implement again this the based on the first name. But why is this, right? Why cannot have a different sorting logic, right, based on based on my convenience? Why, like, let's say that you need to sort employees based on salary, as well as you need to sort employees based on the first name. There are dynamic requirement, right? In some class you need to sort the employee class based on, let's say that, um, the salary, and in other class you need to sort the employee based on the first name. And but then the comparable interface is only sorting based on one instance. For example, if you are sorting based on a salary, then you need to compare the salary, right? And also remember this, instead of writing this huge line, you can also do something like written base dot salary minus o dot salary, right? So o dot salary. So this will also suffice your natural ordering. So I'm going to comment this up, right? Instead of writing if else, you could also do something like this. For example, if this is a positive, right, a positive int, that means that this dot salary is greater than o dot salary. If it is a negative int, right, if the subtraction between these two objects is a negative, then this will be a negative value. That means a less than case. If it's equals, that means if it's zero, that means this is an equals case. And this is how the default sorting will happen. So a comparable interface will help you to do a default sorting. But what if I want to do a sorting which I want to define, right? So you can do that using a comparator interface, and we are going to see that in this demo. So what I'm going to do is, inside this sorting, I'm going to create a package which I will name this as a comparator. And inside this, I'm going to create a new class, which I'm again going to name this as employee. And I'm just going to copy this. So I'm going to copy all this here. And I'm going to create a public static void main method, right? And I'm going to create all these employees, and I'm going to add all these employees here. And let's do collections.sort, right? So I'm going to do a collections.sort employee array list, right? So what I'm going to do is I'm going to remove this, and I'm going to use the employee of this package, which is inside the comparator. So I'm going to remove all this, right? So as this is from a different package, so that's why it is giving me an error. So once I remove this package, I will be able to distinguish between the two employee object. Now this will give me an error because the employee cannot be sorted, right, based on which based on which field you need to sort. And the one way is you implement a comparable interface, but we have seen that if you implement a comparable interface, it will sort based on one field, right? But what if I want to sort, based on a salary as well as based on first name and the last name? So for that, we can use a comparator. As comparator is a functional interface, we can create an anonymous class, right, that implements the comparator interface. And we have seen in the anonymous class section how to create an anonymous class. So for example, I'm going to create a comparator which is of type employee, I'm going to name this as comparator salary, right? Is equals to new of comparator. So what this will do is this is actually creating an anonymous inner class, right, which implements a comparator interface. And inside this, we have a compare method from the comparator interface, right? The inner class, the anonymous class implements the comparator interface. You need to override this compare method. And if you notice, the comparator interface has one only one abstract method, and remember that the other abstract method equals is getting overridden from the object class. That's why the total number of abstract method inside a comparator interface is only one, and that's why it is a functional interface. And remember that if it is a functional interface, you can write an anonymous inner class. So this is basically an anonymous inner class, right? And we will see the functional interface in more details when we do a functional programming, which actually changed the landscape of Java. And that was one of the Lambda expression as well as the functional interface actually changed the whole Java landscape. And this came in JDK 8. We'll see that when we do a functional programming using Java. So here I have created a comparator, or rather a class which implements a comparator interface. And here I can write now, O1 O1 dot salary minus O2 dot salary, right? And now if you notice the sort method, so what I'm going to do is I'm going to remove this, and if you notice there are two sort method inside the collections interface. The first one will take only a list parameter, but the second one takes the list as well as the comparator, right? So what I'm going to do is I'm going to pass this employee array list, and I'm going to pass the comparator instance. So rather a class which implements a comparator interface, and we know that if any class implements a comparator interface, that is basically will be of type the comparator, right? So I'm going to pass here the comparator salary, and now the error has been gone. So basically what is happening is here I'm actually sorting the employee array list based on a salary. And let's try to do a for each here. So for example, employee array list dot for each, right? So I have a for each. You can use for each. This is basically an enhanced for loop, and we will do a print out employee3 dot, let's say, the salary. And let's try to run this code. So when you run this code, you'll get the output as which will be sorted numerically as we are sorting on salary, right? But what if you want to you know do this based on a descending order, rather reverse this? How do you sort? Let's say you want 2000 to come first, then 1500, then 1000. This is very easy. You go here inside this comparator, just reverse this, right? So I'm going to reverse this. So o2.salary minus o1.salary, and this will actually reverse the sorting, right? So when I run this code, you'll notice that this is getting sorted based on descending order. So this is important, right? So this comparator interface gives you this much, the 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 methods to actually sort based on your logic, right? But let's say that you want to sort based on the first name. That is also very easy. So what I'm going to do is, again, I'm going to create a comparator interface of type employee, and I'm going to name this as comparator first name is equals to, I'm going to create an anonymous inner class which implements the comparator interface, and here I'm going to do o1 dot first name dot compare to o2 dot first name, and we'll have here semicolon, and again we will do collections dot sort. Here we will pass the employee array list. Now instead of the comparator salary, I'm going to pass the comparator first name, right? So what I'm going to do is I'm going to use again employee array list dot for each, right? So let's do a for each. Rather, let's do a for each. Here I'm going to have employee m, right? And here I'll have employee array list, right? We'll do here s out m dot first name, and let's actually change here to first name as well. So let me have one more s out here. Rather, I'm going to have an s out above this. So this will to differentiate the above one as well as the below one. Now let's try to run this code. So I'm going to run this code. So I'm running this code. This is getting built and compiled, and you have the output as Michael, because the Michael salary is greater than the rest of the two. Then we have John, and then we have professor, right? Remember, the first comparator is sorting the element based on a salary field. But if you notice at the bottom, we have again created a comparator interface that sorts based on the first name, which is also sorting the elements, right? This is sorting alphabetically, right? J comes before M, M comes before P. But what if you want to reverse this? It's very easy. You just need to reverse this o2.firstname compared to .o1.firstname. And if you run this code, this will be sorted based on the descending. Like the Z will have a greater prefix than X, and so on. So if you notice, when I reverse this, I'm getting sorted. I'm getting the elements inside this array list in a descending manner for the alphabets. Similarly, you can create for the last name. So you can do a comparator last name. I'll leave that to you, and do it for the last name, right? So I'm going to keep this as o1.o2, right? So this is natural ordering. So what I'm going to do is I'm going to write natural ordering based on alphabets, right? And here at the top, this is basically, let's say, ordering, or rather a descending order, right? So I'm going to have type here as a descending order. Again, I'm going to have for ascending, just reverse, just do, rather, I'm going to type this as o1.salary minus o2.salary. So when you get this code, you will be able to recollect it, right? So this is where a comparator interface comes handy, right? If you want to sort uh, based on your logic, right? So like I was able to sort in a single class without implementing any interfaces. I was able to sort, this employee class based on salary. I was able to sort based on first name. And if you implement it for the last name, it will be able to sort for the last name as well, right? Without doing any kind of implementing any interfaces. This is where a comparator interface comes handy. And collections.sort, now, instead of passing just an employee array list, you need to pass the second argument, which is a type, which is of type comparator. So this is what we have done here. So this is all about, the comparable as well as a comparator interface. Both are, the functional interface, which has only one abstract method, but comparator interface gives you a much more flexibility to you know, develop the sorting of the object, right? And the comparator interface, if you are using a comparator interface, you don't have to implement the comparator interface to, you know, sort the objects based on fields, right? So you can say that the comparator interface is pretty much dynamic, and normally people uses a comparator interface. Like, if you consider me, I use a lot of comparator. If I create any class, if I create any of my class, I normally use a comparator interface because it gives me a much more flexibility. But then again, it's not like the comparable, you should not use comparable interface. That's not the case, right? That's not I'm trying to portray. So based on your use case, you can opt for any of these two, right? So this is all about, you know, the comparator interface as well as the comparable interface. So with this, I'm going to, you know, wind up the collections part of Java, and we are going to move forward towards, you know, the functional programming or a functional programming paradigm inside Java. And we are going to start off with a functional interface, but as I have given you an introduction for the functional interface, but we will see like how a functional interface can be used to achieve the functional programming in Java. And we are going to introduce a lambda expression, and a lambda expression actually changed the entire landscape in Java when it comes to a functional programming. That basically introduced the functional programming paradigm to a Java. And that was one of the most important features of JDK8. You will see that when we start with the functional programming in Java. So I'll catch you up in the next video. Till then, goodbye and see you.